Hi everyone. Here we are going to start with DURGASOFT solutions and SQL and PL/SQL training. Today is the day. We are going to learn what exactly SQL is. Okay. First thing is like introduction to the SQL. There is a brief history for this SQL, saying that SQL is all we know. SQL is standard query language. Normally, history of SQL is. SQL initially it started beginning. SQL begins in IBM laboratory in San Jose. Begins its journey. IBM laboratory in San Jose. And next is where SQL was developed in late 1970s. Initially, it stands with structured query language. And the language itself. In fact, SQL makes RDBMS possible, Relational Database Management System possible. SQL is a non-procedural language in contrast to procedural or third generation languages such as COBOL, C that have been created up to that time. Non-procedural means we can simply understand by this non-procedural. Example, SQL describes what data to retrieve and what data to delete. The characteristics a DBMS from an RDBMS. For and two standard organization, that is American National Standard Institute ANSI and International Standard Organization ISO, currently promote SQL standards to industry, and ANSI 92 standard is the standard for SQL use throughout. And although this standard makes body prepared standard for database systems. And next thing is will will discuss about little brief history of databases. Like if we go little background on evolution of databases and database theory will help you to understand working of SQL. Database systems store information in every conceivable business environment, from large tracking database such as airline reservation system to a child's baseball card collection. Database systems store and distribute the data that we depend on. Until last few years, large database systems could be run only on large mainframe computers. These machines have traditionally been expensive to design, purchase and to maintain. However, today's generation of powerful and inexpensive workstation computers enables programmers to design software that maintain and distribute data quickly and inexpensively. So, we have 12 rules for relational database modeling system. Those rules we call Dr. Code rules. So, the most popular data storage model in relational database, which grew from seminal paper A relational model to data of large shared data banks, and these 12 rules were written by Dr. Code, and we call first rule as relational DBMS must be able to manage database entirely through its relational capabilities. First is information rule. All information, we are having 12 rules, right? Those 12 rules are: first rule is information rule. Information rule, all information in relational database include table and column names is represented explicitly as values in the table. First information rule, all information in relational database including tables and column names is represented explicitly as values in tables. And next is guaranteed access. Guaranteed access, where every value in a relational database is guaranteed to be accessible by using a combination of table name, primary key value and a column name. Guaranteed access is that like every information, every value which is there available in the relational database is guaranteed to be accessible by using a combination of table name, primary key and a column name. Can be given accessible is giving an authorization saying that accessible with table name, primary key value and a column name. Next, systematic null value support. This systematic null value support, the database management system provides systematic support for treatment of null values, unknown or inapplicable data. That means unknown data or inapplicable data, distinct from default values and dependent on any domain. This is the systematic null value support. The DBMS provides systematic support for treatment of null values, which is an unknown or an inappropriate, inapplicable data, and distinct from default values and independent of any domain. And the next rule is active online relational catalog. The description of database and its contents is represented as logical level as tables and can therefore be queried using database language. The description of the database and its contents represented as logical levels as tables and can therefore be queried using database language. That's what active online relational catalog. Next rule is fifth rule. We call this one as comprehensive data sublanguage. At least one supported language must have a well-defined syntax and be comprehensive. It must support data definition, manipulation, integrity rules, authorization, and transaction. At least one supported language must have a well-defined syntax and be comprehensive. It must support data definition, manipulation, integrity rules, authorization, and transactions. And the next one is view updating rule. All views that are theoretically updatable can be updated through the system. View updating rule is all views that are theoretically updatable can be updated through the system. Next one is set level insertion, update and deletion. The database management system supports not only set level retrievals but also set level inserts, updates and deletes. It not only supports the retrievals but it also supports set level inserts, updates and deletes. Next, physical data independence. Application programs and ad hoc programs are logically unaffected when physical access method or storage structures are altered. That means application programs and ad hoc programs are logically unaffected when a physical access method or a storage structure are altered. That's what physical data independence is. Next, logical data independence. Logical data independence, application program and ad hoc programs are logically unaffected to the extent possible when changes are made to the table structures. So, logical data independence is the logical application program and ad hoc program are logically unaffected to the extent possible when changes are made to the table structures. And next one, integrity independence. Database language must be capable of defining integrity rules. They must be stored in the online catalog and they can be bypassed. Database language must be capable of defining integrity rules. They must be stored in the online catalog and they cannot be bypassed. That is what we call it as an integrity independence. Next one is distribution independence. Distribution independence, application program and ad hoc requests are logically unaffected when data is first distributed when it is redistributed. That means distribution independence is the one when an application program or any ad hoc requests are logically unaffected when the data first distributed or when it is redistributed once again. So, distribution independence should be there on to any machine, like which is with RDBMS, which is structured data query language, which we are working on. And the next thing is, next rule, non-subversion. This one, it must not be the possible to bypass the integrity rule defined through database language by using lower level languages. That means, when we use lowercase language also, database should understand and it should be able to pull the results for you. Like, it must not be possible to bypass the integrity rules defined through database language by using lower level languages. So, here I hope like you all understood what exactly the code rules defines here when we are working. Okay. And here I can explain you what exactly code defines about the relational database management system. Like here, fact that the physical structure of the data on a disk becomes unimportant. The programmer simply stores pointer to the next location, so data can be accessed in this manner. Also, data can be added and deleted easily. However, different groups of information could not be easily joined to form a new information. The format of data on the disk could not be arbitrarily changed after the database was created. Doing so would require the creation of new database structure. Actually, the idea for an RDBMS uses the mathematical concepts of relational algebra to break down data into sets and related common subsets. Because the information can naturally be grouped into distinct sets, so it got organized his database system around this concept during the relational model. Data is separated into sets and reassemble a table structure. This table structure consists of individual data elements called columns and fields. A single set of a group of fields known as a record or a row. For instance, like to create a relational database consisting of employee data, you might start with a table called name employee that contains following pieces of information, that is name, age, occupation. These three pieces of data make up the fields in the employee table. So here we can say name as William and age 25, his occupation is an electrical engineer, and next we can say Raghava, his age 34 and he can be an carpenter, and next it can be John, so age 45, he can be a chef, and Bill, he can be age 20 and he can be a student, and Don Moin, he can be an 32 and he can be an game programmer. Like this, like we can make different data, different information about all the employees or all the names which we are going to project. For each and every name, they are having their separate age and their occupation. Like this we can enter and we can make the data get stored into the database. So next here so in the next step, like we will do one thing, like we will create the installation of Oracle database and we will start working with SQL and we will see in detail of table structures, everything. So here I hope like till this part you understood what exactly basics of SQL, when this SQL started, why we need an SQL in real time, everything. I hope, yeah, thank you.